What if our entire reality, everything you see, everything you know, is just a fleeting moment inside something far, far larger? I know, it sounds like pure science fiction, but today we're diving into one of the most absolutely mind-bending theories in all of physics. And no, this isn't just some philosopher's wild thought experiment. This is a genuine possibility, and it's rooted in the strange, completely counterintuitive math of black holes. It's physics that forces us, and you, to question the very nature of space, time, and existence itself. So to really get our heads around this, we have to start by breaking down a core belief that most of us have about black holes. This is the first step, seeing the crack that runs right through our common sense view of the universe. You've heard it a million times, right? To make a black hole, you need to compress something. You squeeze the Earth down to the size of a coin, or crush our sun into a space smaller than a city. The idea is that you have to concentrate a ton of mass into a teeny tiny space. And that seems pretty intuitive. But it turns out that's only half the story. Here's the twist, the part that changes everything. The bigger a black hole gets, the less dense it actually needs to be. Yeah, you heard that right. It's an inverse relationship. As the mass skyrockets, the required density just plummets. And what that means is that a truly colossal black hole, well, it doesn't need to be dense at all. This one fact completely flips the script on what a black hole can be. Let's put this into perspective. A black hole the size of our sun, its density would be like packing an entire mountain range into a single cubic meter. Insane. But now, look at a supermassive one, like IRAS 2010-4156. It's 3.8 times billion times the mass of our sun, and yet, its average density is no more than the air you're breathing right now. So in theory, you could make a black hole just by gathering enough air in a big enough space. No violent cosmic squeezing necessary. So, okay, if a black hole can be made of something as thin and wispy as air, that kind of begs a huge question. What happens when we apply that same logic to the biggest, most spread out thing we know of, the universe itself? The amount of stuff in our observable universe is just staggering. We're talking about a sextillion times the mass of our sun. That's a 1 with 21 zeros after it. And that number, that accounts for every galaxy, every star, all the cosmic dust we can possibly see. But for all that mass, the universe is almost unbelievably empty. You average it all out and you're left with just this, about 5 hydrogen atoms per cubic meter. Our entire reality is built on this ultra-thin cosmic fog. And here is the absolute kicker. When physicists run the numbers, when they take that enormous mass and that incredibly low density, they find that it is more than enough to form a black hole. In fact, it's enough to create a black hole 10 times larger than the universe we can see. The conclusion is just unavoidable. Based on the physics, we should be inside a black hole right now. But wait, that creates a massive paradox, doesn't it? If we're inside a black hole, shouldn't everything be collapsing inward on itself? But we look out and we see the exact opposite. Our universe is expanding and fast. How can both of these things be true? Well, the answer might just lie in a mind-bending trick that reality plays on us once we cross that point of no return. To solve this paradox, we have to go somewhere truly bizarre. We have to venture into the most mysterious place imaginable, the inside of a black hole, where the very fabric of reality gets twisted and turned on its head. It all comes down to the event horizon. That's the boundary, the one-way door of the black hole. And once you cross it, you haven't just entered a new place. You've entered a new reality, where the fundamental rules of space and time actually switch roles. Think about it like this. Outside the black hole, you can move wherever you want in space. Left, right, up, down. Time just chugs along, always moving forward. But once you're inside, that flips. Space itself becomes a one-way street, dragging you inward no matter what you do, like you're caught in a river flowing towards a giant waterfall. And time becomes a dimension you can move through. But here's the catch. It's a finite dimension. It has an end. Your future is no longer a boundless timeline. It's a physical destination you are falling toward. And this is so important to grasp. The singularity, that point of infinite density, it isn't a place at the center you're traveling to. It's an event in time that is going to happen to you and to all of space inside the black hole, all at once. The entire universe inside simply collapses. So, everything collapses. Is that the end of the story? Maybe not. Because this inward collapse, this big crunch, well, it looks suspiciously like the Big Bang, just played in reverse. And that symmetry suggests a truly radical idea. This is known as the Big Bounce theory. As the black hole universe collapses in its big crunch, all of space gets squeezed down to an unimaginable limit. But what if, instead of being annihilated, it rebounds? Like a compressed spring, what if space-time itself violently expands outward again? This bounce, for all intents and purposes, would be a new Big Bang, creating a brand new, expanding universe, safely hidden inside the event horizon of its parent. Okay, now let's zoom all the way out. If a black hole can give birth to a new universe, and our universe creates countless black holes, well, you start to see an incredible, self-replicating cosmic cycle. A physicist named Lee Smolin called this cosmological natural selection. The idea is that every time a new universe is born, its physical laws might be just slightly different from its parents. So universes whose laws happen to be good at making stars and therefore good at making black holes will have more children, and universes that can't, they just die out. Our universe, which has already churned out 100 quadrillion black holes, seems to be exceptionally fit in this cosmic game of survival. We might just be the product of a long, long line of successful universe-producing universes. This whole thing can sound a little cold and mechanical, right? Like a cosmic production line. But it has a beautiful and, I think, profound side effect for something we all care about quite a bit: life itself. Just think about it for a second. What do you need to make lots of black holes? Well, you need to make lots of massive stars. And to make stars, you need galaxies. You need cosmic dust. You need complex chemistry. It just so happens that a universe that's perfectly fine-tuned to reproduce itself is, almost by accident, also a universe perfectly fine-tuned to create the ideal conditions for life to emerge. So, the final thought to leave you with is this. What if our existence isn't some miraculous 1 in a trillion fluke? What if we are just an expected byproduct of a grand cosmic evolutionary process? It suggests that we live in a universe that isn't just fertile for black holes, but fertile for life. All is part of an endless, and kind of beautiful, cycle of cosmic birth and rebirth.
Thanks for watching. If you liked it, smash that like button, drop a comment, share with your crew, and subscribe. Hit the bell so you never miss a daily update. See you next time.